So for our third example problem, this is actually a different graph compared to the first two problems we had. For this problem, given is the VS graph, and the VS graph describes the motion of a motorcycle, which is shown in the figure below. So this is the VS graph. And what we need to construct here is the AS graph of the motion, and also we need to determine the time needed for the motorcycle to reach the position, which is 400 feet. So we need to first graph or construct the AS graph first, and then afterwards we need to determine how much time needed for the motorcycle to reach the position 400 feet. So let us construct first the AS graph. So just a solution. Okay, so for the given VS graph, what we discussed last time, if a VS graph is given, you will construct the corresponding AS graph using the kinematic equation, ADS is equal to VDV. And what you will apply here is using derivative. And since this is actually I don't have an example that given the AS graph. If you may encounter an AS graph, you will construct its corresponding VS graph with the same kinematic equation, but what you will apply is the opposite, which is integration. So since VS graph is given in this problem, so we will use the first one. So for here, we have actually two functions. The first one represents the distance from 0 to 200 feet as shown in the graph. So that is V is equal to 0.2s point 10. So using the kinematic equation, ADS is equal to VDV, we will just rearrange the equation. So what we will do is we divide with ds, so that will be A is equal to V dV over ds. And what happens here, we just only substitute the equivalent of V. So that is 0.2 s plus 10 for the equivalent of the variable V. And also here in our derivative, we also substitute the equivalent of V. And what happens here is we differentiate this one with respect to the position. So that is 0.2 s plus 10. And this is 0.2, since 0.2 plus 0, since 10 is a constant, and we just only multiply the 0.2 to each term. So that is A is equal to 0.04 s series this s plus 2. So that is the equation of our acceleration for this given inequality from 0 to 200 feet. On the next one, we have from 200 to 400 feet, the function that describes this inequality is v is equal to 50. And you can actually identify already that the equivalent acceleration for this one is zero. Since the velocity is constant, therefore the acceleration is zero. So it is actually the same thing. We use the same kinematic equation. So we just use this again. Then we substitute the equivalent of v, so that is 50, and d over ds, then 50 here. What happens? The derivative of 50, or if we differentiate 50 with respect to s, that is actually equal to 0. So that's why a is equal to 0. So therefore, we have already our two functions that describes the AS graph. So now we will graph the AS graph. I will go to the Desmos. Okay, so when you graph a when you graph of some functions, you can actually use any type of graphing calculator that can be found online. So if you're using a phone, a mobile phone, you can actually search it in the um, Play Store or in the Apple Store. So what I recommend before or last time is the Desmos. So you can actually use this. This is actually a useful graphing calculator for you to graph any types of functions. So here we will graph the two equations that we solved um, in the problem. So the first one was A is equal to, so that is A is equal, before that, um, you change the label of your X and Y axis. So you go here again to the graph settings. Then you just um, find the X and Y axis. Then here in this um, box, you can type or you can change the label of each of the axis. For the X axis, that is S, and for the Y axis is A. So as you can see here, um, it labels the X and the Y axis. So the first function was A is equal to 0.04s plus 2. And for us to include only specific parts in this line, since it extends in this um, rectilinear, in this coordinate system, rather, we need to type the inequality that is 0 to, so you go here to type the less than or equal to, that is S, then 200. So for this one, it when you extend further or when you zoom out, you can see the graph of the first function, which the um, limit is from 0 to 200. So the same thing with the a is equal to 0. A is equal to 0. That is 200 S, then 400. So it is represented with the green color. So you can actually change the color of each of the lines. So you go here in edit list. Then if you want to change it with red, or you can actually change also the if it is broken or dash line. You can also change the thickness. So if I want to change it with 3, it will be thicker. Here I want it to become blue. So that is 3 also. And as you notice, it's what you need is you can actually change the um, range. So you go back here in the graph settings. Then for the x-axis, what you need is from 0 to 400. And the step is the label, the number that is labeled in each axis. So if I want it that it is by 100, so that will happen. So 0, 100, 200, 300, 400. And for the A, you can change here in the y-axis is 0 to, what was the, I think this is 200. Okay, 200. 0 to 200. You can also change its step again. No, that's not 200. That was 10. Sorry, that was 10. So 0 to 20. Then you can again change the step for the y-axis if you make it by 10. So it will make the graph um, the graph of each line um, seen clearly. And what we want here is we need to draw a line, a vertical line that connects the two lines here. So what we do is we type x is equal to 200. And because if it's s, let's try if it's s. S is it's s 0 a. It will not define if you're using the labels. So what you will do is you just only change it with using the x and y. So x here and then y for the label, for the um, inequality for the range. So it's from 0 to 10 only. So it connects the two lines, the first function and the second function. So what you need is you just change the color. So you need to change it to black. then dash line. Or you need to make it thicker, you can type the line thickness. So I type it with 3 to make it thicker. So this is done. The next is what I want is to label. So for the label, um, what you will do is you need to find a point here that within each line. So for this line, I will choose this point that is 106. So you just only type the point 106. So that is open parenthesis 106, then close parenthesis. As you notice, it shows the label. So you just only click the label. And if you want to remove the dot, you just only click this one. Then for this label, you can type the function a is equal to 0.04s plus 2. And for us that it will have the same slope with your line, so you go to the edit list, go here, um, you click this one. What you can find are the other functions. Here is the label scale factor and also the angle. For the label scale factor, um, it will make the text larger. So I can type 2.5. So as you can see, it will make the text larger. If I'll make it 2, it will get smaller. For the angle, that is the rotation of the text. So if I will choose 0.8, as you can see, it rotates. So I need to find the convenient um, rotation. 0.5 is okay. And here are the like the arrows. You can actually click any of this to move the text. So if you click this one, it will move upward. This one is downward. It's moving to the right, left. No, this is center. Okay. So you can actually use this function. So if I choose this one, or if I click this one, it will move upward. As you can see, I labeled already this line. So I will label also with the other function that is a is equal to 0. So just choose a point here. So this is 300. It must be within the line. So that is 300, 0. Then click label. Then if you want to remove the dot, you click this one. Then you type the text, the function rather. Then you go to edit list. Then you click this one, which is on the left side, which you can find the other settings. So for the label that was 2, then I'll make it, or I'll change it to color black. Then since it is horizontal, I will not um, type in an angle. So what I need is I will just move it upward. So I'll just click this one. And that will be your graph, your AS graph. So you will just go to share graph, then export image. If you notice, um, the angle of the first text is um, not the same on the actual on the first one. So we need to go back here. We need to find a we'll try zero point 0.6 if it matches here in the export image. Um, try it again. It's more on the trial and error. Zero point 0.7. Okay, so this is fine already. You can change if it is large square, small square, medium. If you want to make it smaller, if you want if you want the text to make it smaller, so you just only change here in the edit list, then make it 1.5. The same here also one oops. Same here also 1.5. Export image. So this is already okay. So you can choose the size and also the line thickness if you want it thin, medium. This is the medium, and also the thick. So once you're um, done already, if you're satisfied with your graph, you can download. You can click the download PNG. Okay, so that is how you use the Desmos, especially when you label each function. You can actually discover the other settings in the Desmos, especially how you graph any types of functions. So we go back to the presentation again. Okay, so this was the graph. So this is the AS graph. As you notice, um, during the for the distance 0 to 200, the acceleration increases, but um, at the during the position 200 to 400, the acceleration is zero since based from the VS graph, the velocity is a constant, which is 50. So we continue on finding the time needed for the motorcycle to reach the position 400 feet. So that is actually a continuation. Okay, so after we construct the AS graph, we need to determine the time needed for the motorcycle to reach the position 400 feet. So just a continuation of our solution for this problem. So for us to determine the time needed to reach the position 400 feet, we need to choose again the from the three kinematic equations. So it must have the time. So we need to choose from V is equal to ds over dt, A is equal to dv over dt, and ads is equal to vdv. Since the first two has the time, the variable time, what we need is we will use the first kinematic equation since we will base on the VS graph. So it has the velocity and it has the position, and what we need is the unknown, which is the time. So we need to use the first kinematic equation here. So we need to first, we need to start from the first inequality, that is 0 to 200. That is 0 to 200 feet. That is v is equal to 0.2 s plus 10. So using the first kinematic equation, we just only substitute the equivalent of v, that is 0.2 s plus 10 is equal to ds over dt. Then we cross multiply, or we combine the like terms for the same variable. So that is dt is equal to ds over 0.2 s plus 10. So for us to determine the time, we need to integrate each side. And when we integrate, we can choose either definite or indefinite integral. So I will choose definite integral for this one. Since it's based on the problem or based on the graph, since it starts from 0, so that will be its initial position, that time will be also equal to 0. So we will use that for us um, to represent the lower limit. For the left side, the lower limit is 0, then the upper limit is t. Then the right side, that is 0 for the lower limit. And for the upper limit, you can actually substitute directly the 200, or you can use the variable s. But here I will substitute directly the 200, so that the time that I will use, or the time that I will determine here, is um, the time which the position is 200 feet. So that I can use that for the next inequality, which is 200 to 400 feet. So that is ds over 0.2 s plus 10. So for us to solve the right side, we need to let u is equal to 0.2 s plus 10. Then we need to differentiate the equation. So that is du is equal to zero point 0.2 ds. So to represent the, or the equivalent of ds, that is du over zero point 0.2. So this is the one that we will substitute here in the ds here in our equation. So what happens here, this becomes 0 t dt is equal to 0 200. So that is du over zero point 0.2 over u. So since 1 over zero point 0.2 is constant, we can actually um, what do you call this? Um, Write it outside of the integral sign. Just a continuation. So that is 0 t dt. And 1 over zero point 0.2 is actually equal to 5. 0 s du over u. The integral of du over u is ln u. So we can integrate this equation. So this is t 0t, and this is ln u 0s. And then we substitute the equivalent of u. That was, this is 200 rather. 200 for the upper limit. So the equivalent of u is 0 0.2 s plus 10. Then we substitute the upper lower limit. So upper minus the lower, so that is t minus 0, so that is t. For the right side, that is 5 ln point 2 200 plus 10 plus 5 ln point 2. Then for the lower limit, which is 0 plus 10. Therefore, the time when the position is 200 feet, that is um that is minus instead of plus, because that is upper minus the lower, so that is a minus sign. Minus 5 ln point 2 0 plus 10. So that is 8.05. So this is the time that we will use to represent for the position 200 feet for the next inequality. So just a continuation of our solution. So from 200 to 400 feet, that is v is equal to 50. So the same kinematic equation. So we substitute the equivalent of v, that is 50. Then we can actually cross multiply. Can write this in this way. Then we integrate again. Then when we integrate, you can choose either definite or indefinite integral. And for this one, since the inequality is 200 to 400, the time when the position is 200 feet, that is 8.05. So that is our lower limit. And the upper limit is t, which is the unknown. For the right side, the lower limit is 200. And for the upper limit is we will substitute directly the 400. So that the time that we will, the answer that will come up here in our equation is the time needed for the motorcycle to reach the position 400 feet. So we will solve this one. So that is T 805 T is equal to 1 over 50. You can actually leave it there. So it's still S over 50, 200, 400. Then you substitute the upper lower limit, T minus 8.05. So it is 400 over 50 minus 200 over 50. Then you transpose 8.05 to the other side. So that is, or it will become positive 8.05. So the time needed for the motorcycle to reach the 400 feet, so that is 400 over 50 minus 200 over 50 plus 8.05. So the time needed is 12.05 seconds. So this is the time needed to reach the position 400 feet. We will check the answer if it is correct. So that is 12 seconds. So that will be your answer. So what we did is we construct the AS graph from the VS graph given in the problem. And also we determine the time needed for the motorcycle to reach the position 400 feet, which is 12.05 seconds.